Hi and welcome back. Hector here from HelpMeGraduate.com. I'm going to do a third and fourth example using the out-of-the-box alternative methods for finding derivatives of functions, weird functions, tricky things, out-of-the-box things that you want to do to impress your professor or maybe your girlfriend. Although, now that I think about it, I wonder how many girls can be impressed by doing derivative with alternate methods. Probably not that much. There may be a few, but well, that's another topic. So, I picked a few examples from the book, and they're pretty much similar to what we saw before, so I want to reinforce what was being worked on before, okay? On the past example and the first example as well. I'm also going to leave you an exercise, okay, a variation of one of the examples we're going to do, because I think it's fair that you also come up with your own solutions. And if you want to comment on it, or if you want to message me about it, you can just simply send me an email or comment on the video itself. So the first example that we're going to use is x powered to x. Okay, this is a weird function. Whoa, x powered to x. I wonder how does that go? Well, now that I think about it, well, 0 powered to 0, well, that's tricky. We're going to talk about that later. But 1 powered to 1 is 1. 2 powered to 2, well, that's 4, right? 3 powered to 3, well, that's 27, right? 4 to 4, well, 5 to 5, and so on, right? It's a very increasing, fast-paced function, as you may have imagined, okay? And let's not get started if it's considering the negative numbers, okay? But, well, we'll get to that in another section probably, okay? So, again, the table of properties that we used before, you can go check in the past video. Again, I'm going to be using just basically, in essence, a property that says natural logarithmic of a going to be equal to b natural logarithmic of a, and I'm going to be also using the property that says natural logarithmic of x prime is equal to f prime over fx. Okay, I'm going to be using those two properties. Okay, but it's pretty simple, as you can see. It's even a little bit easier than the past example that we had in the second video. But it's just for practicing purposes and for you to get the grip of it, and also to help you on the exercise I'm going to leave you. Okay, so again, what we do here, what do we do with the x? Well, I can't use the exponent rule, so I have to use the natural logarithmic property. Okay, so I'm going to use natural logarithmic of y, applying natural logarithmic to both sides of the equality. Natural logarithmic of x powered to x, and this, according to that property right there, okay, it's equal to, say, x times logarithmic of x. Okay, I just skipped a step just for purpose, okay, just to have a bit more clean, organized board. Okay, next step, I just take the derivative. Let's change the color of the marker just to be different on it. And we have on the left side, derivative of logarithmic of y is going to be 1 over y times the internal derivative, which is y. Okay? I already said that y is not the variable, so y prime is the derivative of y. Left side of the equality. Right side of the equality, you see the product? I'm sure you do. F and g. Okay? And we're going to do it quick, because by this time, if you're looking at this video, you're probably up to the pace of doing product derivatives just like that. Okay? Derivative of the first multiplied by the second one plus derivative of the second one multiplied by the first. So, derivative of the first, x, is 1 multiplied by the second function, which is logarithmic of the natural logarithmic of x, plus second function, derivative of logarithmic of x is 1 over x. We saw that in the past video. Multiplied by the second function without being derivative. And that is x, the first function, sorry. Okay? So all we have to do left is simplify. As you can see, the 1 makes no sense to have here, so I'm just going to delete it. And as long as x is not 0, okay, I have to make that little quotation right here. As long as f, or you can even write if x is not 0, they cancel each other. Okay? And now we're left with y prime over y. So the y goes all the way, multiplying the right side of the equality. So this goes away, and here we're going to have y. But what is y anyway? Right there. Okay? And that is the solution for the exercise. X power 2x multiplying, or common factor of natural logarithm of x plus 1. There you go. That is the solution. Okay? The second example that we had, let's give a few seconds, and then I can erase. 1, 2, 3, 4, 5. There we go. Second example is going to be a little bit similar. Only thing is, I'm going to have, you guessed right, trigonometric function. Y equals sin x power to cos x. Okay? Nothing scary at all. It's just trigonometry. And now I'm going to apply logarithmic. Okay? So let's do that. Natural logarithmic of y equals natural logarithmic of sin x power to cos x. But according to this property right here, I can put this all the way down here. So I'm just going to do it right away. There's no way in holding back. Cos x multiplies logarithmic of sin x. And now I do y prime. Okay? I'm just going to skip the prime thing because I guess you should be used to it by now. So, y prime over y equals, and right here we have a product once again, okay? With this being f, and this being g. Okay? So let's put the addition sign right here. I think it should be a fair enough space, right? Derivative of the first one is minus nx. Looks like I didn't have enough space after all. Funny. Multiplied by the second one without being in derivative. So it's natural logarithmic of sin x. Okay? Plus derivative of the second one, which is this one, derivative of sin x, let's do that real quick, is 1 over sin x multiplied by the internal derivative. The internal derivative of sin x is cos x. So we're going to have cos x over sin x. Okay? Again, the derivative of natural logarithmic of sin x is 1 over sin x multiplied by the internal derivative of sin x with this cos x. But this is cotangent, so I'm just going to rephrase this, okay? Cos over sin is cotangent. Trigonometry from high school. Multiplied by the first function without being derivative, which is cos x. There we go. All that's left is simply that y over here, dividing, pass it up here, multiplying. That's what I'm going to do. So long. And come here. Just do my parenthesis to be organized. Y, I have it right there. Sin x power to cos x. And there you go. That is the solution of the problem. Let me fix this a little. Okay? There is the solution of the problem. How many lines did it take me? 1, 2. That's it. Alternative methods. They're very good. Exercise for you. Please send me your comments, questions, feedback. And if you have any issues, I'll help you with it, but hopefully you'll be able to do it. By now you may probably know what I'm going to leave you as an exercise. Something very interesting. Find the derivative of this function. That is correct. Find the derivative of x power to x power to x. Good luck. Send me your comments to helpmegraduate.com. Visit my website for more videos. Have luck.